Hello students, welcome to my channel Engineers Academy. Kindly subscribe my channel for the solution of such more problems. Now let's solve this particular problem from the friction topic. In this problem it is said that the uniform pole of length L and mass m is placed against the supporting surfaces is shown. If the coefficient of static friction mu s equals to 0.25 at both A and B, determine the minimum angle theta at which the pole can be placed before it begins to slip. Right, so we have to determine this theta before this pole will start slipping, right? So now for this what we will do is that we will draw a free body diagram, right? So this will be my free body diagram, right? And that pole is represented by this purple line, right? And we have that point A here. Let's see, this is that point A, and here we have that point B, right? So if the pole starts slipping towards the right, so what will happen is that we will have those friction forces, right? And if it is moving towards the left, so the friction forces will act in the opposite direction to the motion, right? So here we will have that friction force like this, right? Let's say this will be FB, and here we will have that normal force which will be acting perpendicular to this surface. Let's say this is NB. So if this is NB, then we can write that FB will be equal to mu S NB, and here we have the normal force which will act perpendicular to this surface, right? So this will be that NA. Let's say this is NA, and if the pole is slipping towards the right, so this end will move downward, right? So what will happen is that the friction force will be acting upward parallel to this surface, right? So this will be FA, this will be FA, and here we have that angle theta which we are required to determine, and here we have that 105 degree angle given, right? Both of these surfaces are making 105 degree angle with each other. So now if I apply, before slipping this pole will be in equilibrium, right? So we will be considering the equilibrium conditions, right? So if I apply the summation of forces along x equals to 0, right? So for that we have to resolve this NA, since this NA is making some angle with the horizontal. If I draw a horizontal line here, right? If I draw a horizontal line here, right? And we have to resolve this FA. This FA is making some angle with the vertical as well, right? So if I draw a triangle here like this, so as we can see that this angle is 105, and the summation of both of these angles will be 180. So this angle will be 180 minus 105, so this will be 75 degrees. This is 90, and this angle will be 180 minus 90 minus 75, so this angle will be 15 degrees, right? This is 15 degrees. So this means that this FA is making 15 degrees with the vertical, right? So I can write that this angle is 15 degrees. So now we can resolve this FA into its components as well. And this FA will have two components. It will have one component which will be acting upward. This one will be the cos component, and it will have one component which will be acting in this direction, right? Let me define my coordinate system. So this is my positive x and this is my positive y, right? Now as we can see that this NA is perpendicular with this surface, right? And this horizontal line is perpendicular with this line, so the angle between these two is 15 degrees. So this means that this NA is also making 15 degrees with the horizontal. So we can resolve this NA into its components as well, right? So it will have two components as well. So this NA will have one component which will be acting like this. This one will be the cos component, and it will have one component which will be acting vertically upward as well, right? So let me represent that component here, right? It will have one component which will be acting here, but let me represent it here, right? So these are the two components of this NA, and these are the two components of FE, right? And similarly, since this pole has its weight as well, so we have to represent that weight, and that weight will be acting vertically downward at its mid length, right? So this length will be L divided by 2 and this length will be L divided by 2, remember, right? Let's say that this point is G, that is the center of gravity, right? So then this BG length will be L divided by 2 and this AG length will be L divided by 2. So now if I apply the summation of forces along x equals to 0, so this one is the cos component of NA. Let me write this is NA cos of 15 degrees, this green one, right? So I have to write NA cos of 15 degrees. This one is the sine component of FA, right? So we have to write this is FA sine of 15 degrees. And again we know that FA will be equal to mu S and A, right? So we can write this as minus FA sine of 15 degrees. Similarly, this is mu S and B. So I will write that this is mu S, this is in the negative x direction, right? So we have to write mu S and B, and this whole equation will be equal to 0, right? So we have 1, 2 and 3 components or forces in the x direction, right? So we can simplify this. This FA is mu S and A, so we can write it as mu S and A, and mu S value is given, which is 0.25, right? So if I take an A common from this, so this will be an A, and we can write that this is cos of 15 degrees minus, we will be left with mu S, and mu S is 0.25 sine of 15 degrees minus this is 0.25 and B, and this is equal to 0. And if we bring this to the other side of equation, so we will have it like this, right? So if I divide both sides of equation by 0.25, right, so we will have NB in terms of NA, right? So let me calculate this. So we are having cos of 15 minus 0.25 sine of 15 divided by 0.25. So NB equals to 3.60 NA. So I can write from this equation that NB equals to 3.60. Let me write it as 3.605 NA. Right? So we have this important relationship between NB and NA. Now if we apply the summation of forces along y equals to 0, so as we can see that this is the sine component of this NA, right? I have picked it from here, right? So it is here. So this is the sine component, right? So we can write that this is NA sine of 15 degrees. Similarly, this component, this is the cos component of FA, and FA is mu S and A. So I will write plus mu S and A cos of 15 degrees. And similarly, this NB is acting in the positive y direction, so I will write plus NB. And this weight is acting downward, and this weight is m times g, right? So we have to write minus mg, and this will be equal to 0. Again, we can take an A common from this, or if I replace this NB by this equation, right? So we can write, if I replace this NB by 3.605 NA, and now I take NA common, right? So this NA, so this will be sine of 15 degrees, mu S is 0.25 cos of 15 degrees, and this will be plus 3.605 minus mg equals to 0. And if we bring this to the other side, so it will become positive, right? So now we can find this. This is sine of 15 plus 0.25 cos of 15 plus 3.605. This is equal to 4.105. So 4.105 105 NA equals to mg, and we can write this NA in terms of mg, right? That is the weight of that uniform pole. So this will be mg divided by 4.105, or we can say that 1 divided by this answer. So this is 0.244 mg, right? So I can write that this is 0.244 mg. Similarly, if I put this Na in this equation, so we will get Nb in terms of Ng, right? So this Nb will be equal to 3.605 into Na, which is 0.244 mg. So I will multiply this answer with 3.605. So this is 0.878, right? So this is 0.878 mg, and this is Nb. So this is Nb in terms of mg, and this is Na in terms of mg. Now we are going to find this theta, right? So to find this theta, what we need to do is that we need to apply the summation of moment about point C equals to 0, and we will consider that this is our point C. As we can see that this Fa is passing through that point C, so it will not produce the moment about that point C, right? So let me remove this Fa and its component as well, right? They are not producing the moment about that point C. Similarly, this Na is perpendicular with this surface, right? So this Na is producing the moment about that point C. Similarly, this Fb is passing through that point C, so it is not producing the moment about that point C as well. So we are only left with this Nb. It is producing the moment about that point C. This weight is producing the moment about that point C, and there is no need to resolve this Na into its components, right? Since this Na is perpendicular with that surface, and the moment arm will be this AC. So now if I apply the summation of moment about point C, so as we can see that this Na is producing the clockwise moment about that point C, so I will write minus Na, and the perpendicular distance of this Na from that point C is this AC length, right? So I will multiply this with AC, and similarly this Nb is producing the counterclockwise moment about that point C, so I will write plus Nb, and the moment arm of this Nb from that point C will be this BC length, right? So I will multiply this with BC, and similarly this weight is producing the clockwise moment about that point C, so I will write minus mg, and the perpendicular distance of this weight from that point C is this distance, right? And let's say that this intersection point is P, so this Cp length, so we have to find the Cp length, and this will be equal to 0. So to apply this equation, we need to know this AC length, we need to know this BC length, and we need to know this Cp length, right? So we can find, if I apply the sines law, right? If I apply the sines laws to this triangle, right? So this is L, and this is that AC length, this is that AC length, and this is that BC. So if we apply the sines law, so according to sines law, if I write L divided by sine of 105 degrees, this will be equal to AC divided by sine of theta, right? So this AC length will be equal to, we can write that AC length will be equal to, if we cross multiply, so this will be L sine of theta divided by sine 105 degrees. And similarly, if I apply again the sines law to the other side, this BC, so we can write that L divided by sine of 105 degrees equal to this BC length divided by the sine of this angle. So this angle will be, let's say if this angle is beta, so then beta will be equal to 180 minus 105 minus theta. So 180 minus 105 is 75 minus theta. So this beta is 75 minus theta. So I will write that this will be sine of 75 minus theta, and from this we can write that BC length will be equal to L sine of 75 minus theta divided by sine of 105 degrees. And similarly, this CP length, we can find this CP length. So this CP length will be equal to, if I write that BC length, this whole BC length is equal to CP plus PB, right? So then we are interested to find this CP length, then CP length will be equal to BC minus PB, and we know BC, right? This is that BC. So BC will be L sine of 75 minus theta divided by sine 105 minus, this is PB, right? So minus this PB. So this is half length, this is L divided by 2. So this is the cos component of L divided by 2. So PB is L divided by 2 cos of theta. So now this is that CP, which is the moment arm of that weight of that bar. Now we know all of these moments arm, right? So we have to put all these in this equation, right? And the remaining is just simplification of this equation, right? So I will write minus NA. So NA is 0.244 mg, 0.244 mg, and we know AC. This is that AC, which is L. I will write this as L sine of theta divided by sine of 105, and sine of 105 is 0.966. Remember, right? This sine 105 is equal to 0.966. You people can find it by using the calculator, right? So if I remove these brackets, so then we will be left with this term. This is mgl sine of theta divided by 0.966, 0.966, right? Then we will write plus NB, and NB is again in terms of mg, which is 0.878 mg. So I will write 0.878 mg, and BC, right? So this is that BC. So I will multiply this with L sine of 75 minus theta divided by sine of 105, which is again 0.966, right? And minus mg into Cp. So this is that Cp. So we will multiply this with L sine of 75 minus theta divided by sine 105, which is 0.966, minus L divided by 2 cos of theta, and this will be equal to 0. If we take L common from both of these terms, so we will have mgl, this is sine, and we will be left with cos of theta divided by 2, right? And here we have that sine 75 minus theta, right? So let me simplify this as well, right? So sine of 75 minus theta, this is equal to, this is sine alpha minus beta formula, right? So this is sine of 75 cos of theta minus cos of 75 sine of theta, right? And sine of 75 is 0.966, right? Sine of 75 is 0.966. So this is 0.966 cos of theta minus cos of 75. So cos of 75 is 0.259, right? So 0.259 sine of theta. So we can replace sine 75 minus theta by these two terms, right? So now if I divide this whole equation by mgl, right? So this mgl will be cancelled out, this mgl will be cancelled out, and this mgl will be cancelled out, and we will be left with an equation with only one unknown, which is that theta, right? So now we can simplify this. If I divide both of these, so this is 0.244 divided by 0.966. So this gives us 0.253. So this is 0.253 sine of theta plus 0.878 divided by 0.966. So this is 0.909 sine of 75 minus theta minus, and this is 1 divided by 0.966, right? So 1 divided by 0.966, so this is equal to 1.035. so 1.035 sine of 75 minus theta, and this minus into minus will become plus, and 1 divided by 2 cos of theta, so this is 0.5 cos of theta, and this is equal to 0, right? So now we can further simplify it. So this is 0.253 sine of theta, and both of these will add up, right? So this is 0.909 minus 1.035. So this gives us minus 0.126 minus 0.126 sine of 75 minus theta, and plus 0.5 cos of theta, and this is equal to 0. So now we have to replace it by this, right? So I will write it as, I will multiply this with 0.966 cos of theta minus 0.259 sine of theta. So again we can add both of these terms, right? So this is minus 0.253 sine of theta, and if I multiply this, so this is minus into minus plus, and 0.126 into 0.259 sine of theta, and this is minus into minus 0.126 into 0.966 cos of theta, and plus 0.5 cos of theta, and this is equal to 0. Now if we add up both of these terms, so this will give us minus 0.22 sine of theta minus 0.22 sine of theta, and similarly if we add both of these terms, so this is minus 0.126 into 0.966 plus 0.5. So this gives us 0.378 cos of theta. This is plus 0.378 cos of theta, and this will be equal to 0. So if we bring this term to the other side, so its sign will become negative. So we will have the equation like this. And if I divide both sides by cos of theta, so this will be cos of theta, and we will be left with this. So this sine of theta divided by cos of theta is tan theta. Minus sign will cancel out, and we will be left with tan theta equals to 0.378 divided by 0.22, and if I take tan inverse, so we will be able to find that theta which is required, right? So tan inverse 0.378 divided by 0.22. So this gives us 59.8 degrees, right? So theta equals to 59.8 degrees. So now in the problem statement it was said it was required that determine the minimum angle theta at which the pole can be placed before it begins to slip. So if this angle is 59.8 degrees, right, so it will not slip. The angle is decreased from 59.8, so it will start slipping, right? So this is the solution of this particular problem. I hope you people would have understood the solution of this particular problem. Kindly subscribe my channel if you haven't subscribed it yet.